Oops. Oh, hey, welcome to lesson 1.4, reflections. Okay, we're going to be doing all the fun stuff you need to know about reflections. Let's get into it. So, a transformation in which a geometric figure, all right, is flipped over a line, creating a mirror image. That is a reflection. All right, we flip it over a line and it's a mirror image. So if you look over here, we got our heart. It's flipped over this line, and it becomes this flipped over mirror image. Now this line has a special name. This is called the line of symmetry. Why is it called that? Well, if you look here, everything is symmetrical on this line, meaning it looks the same on both sides. This side looks the same as this side. Now here's the most important thing to know about this lesson. After a reflection, all points in the image are the same distance from the line of symmetry as they were in the pre-image, but just on the opposite side. What do I mean by that? So let's say in the pre-image, this point is, let's say, 2 inches away from the line of symmetry. On the opposite side, it will also be 2 inches. All right? If this point over here to the line of symmetry is 5 inches, all right, on the opposite side, it will also be equal distance, the same distance. It will also be 5 inches. Got it? All right, so we're going to do a reflection over the x-axis. What we're going to do here is reflect point A over the x-axis. We're going to state the coordinates of A and A prime. So where is that pesky x-axis? Well, that would be right over here. This is our x-axis, right? You can see that's our x-axis. All right. The way to reflect something, remember, is just find the distance from the line of symmetry. So the x-axis is our line of symmetry, and A is 3 away from it. 1, 2, 3. To find the reflected point, all right, A prime will just also be 3 away, but just on the opposite side. So we'll just go 3 more. 1, 2, 3, right? If it's 3 away here, it's going to be 3 away on the opposite side, and that is A prime. So let's see our points. A is 4, 3, and A prime is 4, negative 3. All right, so what happened to the coordinate here? Well, what just happened, if you just look at these coordinates and not the points, all right, all we see is that x stayed the same, x stayed the same, and y became negative. All right? And that's going to be true for all reflections over the x-axis. And why is that? Well, let's try another point. All right, let's say I put a point here. It's 2 away from the x-axis. If I want to reflect over the x-axis, I just go 2 down. So my y-coordinate goes from positive 2 to negative 2. And if I started over here, if at negative 2, it would become positive 2. Got it? So all you have to do is change the sign of y. The way we write this rule, and this is a rule, is just to say x, y. That's how it starts. All right? It just becomes x, negative y. And that just says to reflect over the x-axis, we just change the y. We change the sign of y. All right. Reflections over the y-axis. Let's give this guy a shot. All right? So we got point B right here. Oh, that's not the right part. It's right here. All right, point B is right here. That's at 1, 2, 3, negative 3, 1, 2, 3, 4, 5. So B is at negative 3, 5. All right, we want to reflect point B over the y-axis. State the coordinates of B and B prime. So this is our y-axis. And remember, in a reflection, all right, the pre-image is always the same distance from the line of symmetry as the image. So B is 1, 2, 3 away. That means our B prime will be also 3 away. So we just count 3 more. 1, 2, 3. And that is our B prime. Well, let's find out what coordinate that is. That is 1, 2, 3, up 5. So it's 3, 5 in this case. And what happened to the coordinate? Well, in this case, the sign of x changed, right? but this time y stayed the same. And that's going to be true for all reflections over the y-axis. For example, let's say I was over here. All right, we'll call this point A, which is 4 away, 1, 2, 3, 4. All right, so let's see this point. This is -4, 1. All right, if I reflected it, all right, so it goes 1, 2, 3, 4. It goes 4 more, 1, 2, 3, 4. All right, it goes here to B. Oh, sorry, A prime. Well, that's at 4, 1, right? Positive 4, 1. And look what happened. We just changed the value, the sign of x. That's all you have to do. So that's going to be our rule for reflecting over the y-axis. X, y turns into change the x, y stays the same, right? That's a rule. That's a rule. And rules are just to make it easier. You could always use this counting method, but if you want to have a rule, it's a good thing to memorize. In this example, we're going to reflect ABC over the y-axis. State the coordinates of the pre-image and the image of triangle ABC. All right, so let's start by finding the coordinates of ABC. And if you count this out, you'll see that it's -8, 5, -8, 2, and -3, 2. So those are the coordinates of ABC right here. All right, I happen to have counted that earlier. That's how I did that quickly. Now, if I want to reflect this over the y-axis, which is right over here, we could, all right, we could count each one of these points, see how far it is away. So A is 1, 2, 3, 4, 5, 6, 7, 8. Do that whole thing. You could do the counting method, or we could just use the rule. And the rule we just figured out was we just change the x, keep the y, right? So we could just do it this easy way. Let's use our rule. So we change the value of x. So A is -8. That becomes +8. And remember, our y stays the same. -8. That's our y stays the same, and we change our x again. So -3 becomes +3, and our y stays the same. Well, that became really easy, right? I happen to love these rules. So let's graph that out. 1, 2, 3, 4, 5, 6, 7, 8, up 5. All right. And then we have 8, 2, and then we have 3, 2. And so that's going to be A prime, B prime, and C prime. And let's put those lines in there. Boom, bang, beam. And look at that. Look how pretty that looks. It's perfect, right? It is the mirror image over the y-axis. That is our line of symmetry. Now the next question says, is this a rigid transformation? You should be getting the point now. The answer is yes. This is a rigid transformation because when we reflect something, it stays the same size and shape, but I'm not going to say that. That's the middle school language. We're using high school language because yes, it preserves the distance between points. Beautiful. So we've done the reflections over the x-axis, we've done it over the y-axis. Now we're going to just do it on more random lines, okay? So in this first problem, we're going to reflect C over the line x equals 2, and then plot C prime and state the coordinate. It's not so bad if you remember how to graph x equals 2. And the way to do that is remember that x equals anything will always be a vertical line. So you just go to 2, all right, and you just draw a vertical line at 2, all right? So that's going to be where we reflect. And we use a dotted line for the line that we're going to reflect over. We're just going to put a dotted line. All right, so x equals 2 is just a vertical line at 2. All right, x equals anything will always be vertical. So to do C prime, all we do is count. So it's going to be 1, 2, 3, 4 away. All right, so since it's 4 away from the line of symmetry, we just count 4 more. 1, 2, 3, 4. And that is going to be C prime. All right, no rule, you just got to do the counting method. So C prime is at -2, 2. All right, let's try one more. We're going to reflect D over the line y equals -3. Plot D prime and state the coordinate. So y equals anything is a horizontal line. So we go to -3, and now we draw a horizontal line there. All right, so let's go to this. At -3, it's a horizontal line. All right, you might remember this, you might not. The way to do the reflection is you just count, right? So D is 1, 2 away from the axis symmetry. We count 2 more, 1, 2, and that is going to be D prime. All right, D prime is at 1, 2, 3, 4, down 1. So 4, negative 1. Sadly, there's no rule for this. You just count it out. But as long as you can graph x equals and y equals, you'll be good. And you got this pro tip right here to remind you. Okay, just like last time, we're going to be going off the grid. Right here, we want to describe a transformation that maps triangle ABC onto triangle DBC. Triangle ABC is right here, ABC. All right, and triangle DBC is right here. All right. So what transformation will map them onto each other? Well, if you look here, if I just flipped over ABC, I would get, it would map onto it, right? This is clearly a flip. All you got to do is find where am I going to flip it over. And in this case, if I flipped over CB, right? This is our axis of symmetry in this case. All right? They would map onto each other. I could just flip it over, CB, right? So in this case, all you have to do is reflect, a reflection over the line CB would map triangle ABC onto triangle DBC, right? Just flip it over. The only thing that you really got to think about here is where is that line of symmetry? Where's that line that you're flipping in? And here it's clear it's CB. It's not going to be AB. You got it. So in this case, I want to describe a series of true transformations that map LFT, triangle LFT, onto triangle YZX. Now in this case, I'm going to need 2 because if I were just flipping this guy over, right? Let's say I just flipped this. Oh, if I just flipped it over this line over here, oh, they don't map onto each other. They're too far apart. So I got to get them next to each other. And the way we could do that is by translation, which we learned about in the last lesson. So if we just translate this along the line TX, and remember we know that because T and X are both last, they're going to correspond to each other. We just move this triangle along the line TX, move it, move it, move it, a translation right there. Well, we're in good shape. Now we're in pretty good shape. So the first step was a translation along the line TX. All right. Now let's get rid of this line. The second step, let's move our points down. The second step is to find the line of symmetry. How am I going to reflect it over? Well, if I reflect it over this line in the middle, all right, and that was XZ, if we reflect over the line XZ, well, let's see. Let's try that reflection. I'm going to flip it, all right, and I'm going to flip it over this line, and look, they go right onto each other. So, 2 things. We just had to translate it down and then reflect it over the line XZ. And remember, you have to define which lines you're reflecting over and translating, or else it doesn't really make much sense. All right, guys, remember, feed your cat well, and I don't know, don't cry in public. No, you can cry. Feel what you want to feel.